The Zoom session is being brought to you by the Fractal Inverse Bullseye S Swirl. Okay, for today, we move on with chapter 5, 3, and 5, 4, 5, 3, 5 sections 3 and 4. Partial fractions and nonlinear systems. Partial fractions is something you'll be using when you get to the calculus. This is trying to write a fraction of this sort. 2 over x minus 1 times x plus 1 is supposed to be identical to some constant over x minus 1 plus some other constant over x plus 1. The idea being, if you want to integrate this thing on the left, it equals the sum of the integrals at z2 on the right and these two on the right. It's easy to find integrals, so that's why you use this this decomposition. The question is, what constants A and B work to make this an identity, true for all values of x? All right, the trick is, okay, hold on a second, McDonald. All right, the trick is, will we rescale both sides of the equation, multiply both sides by x minus 1 times x plus 1. So on the left, the denominator is canceled, and we're left with 2. So this will be identical to these here. This will be a times x plus 1 because the x minus 1 canceled, plus b times x minus 1 because the x plus 1 canceled. All right, now here on this side, we distribute the a's and the b's, ax plus a plus bx minus b. We combine the x terms and the constant terms. And the left side will write as 0x plus 2 is identical to a plus b times x plus a minus b. All right, so having gotten that far, the idea is that if these are identical expressions, then they will be the same for all values of x. For them to be identical expressions and therefore true for all values of x, it therefore must be that the coefficients have to be equal to. The 0 has to be the same as a plus b, and this 2 has to be the same as a minus b. So a plus b equals 2 and a minus b equals, a plus b is 0, a minus b is 2. That's what you get. A 2 by 2 linear system. And after some very simple operations, we get the a equals 1 and b equals negative 1. And it works. 1 plus negative 1 is 0, and 1 minus negative 1 is 2. So therefore, we can say that 2 over x plus minus 1 times x plus 1 is indeed identical to 1 over x minus 1 plus negative 1 over x plus 1. And so if you want to integrate this left side, you simply do the sum of the integrals on the other side. Now, okay, from this point here, 2 is identical to a times x plus 1 times b times x minus 1. But instead of identifying coefficients, we could just use by using values of x. For a, x equals 1. After a bit of work, it gets 2 equals 2a plus 0, which means a equals 1. For x equals negative 1, this is 0, this is negative 2. 2 equals 0 minus 2b, which yields b equals negative 1. So it works. It works just as well. If we have a repeated linear factor, such as 2x minus 3 to the second power, then we use a different formula to have a over 2x minus 3 plus b unknown over 2x minus 3 squared. And then if you distribute and multiply throughout by 2x minus 3, we get that x plus 4 is identical to a times 2x minus 3 plus b. Now, okay, we could identify a and b by using coefficients of x or by using values of x. Okay, in this case, if we set x equal to 2, then into here, then we get that 6 equals a plus b. Set x equal to 1 in here, you get 5 equals minus a plus b. 6 equals a plus b, 5 equals minus a plus b. It's relatively simple to identify a and b as a half and 11 halves. Just by adding the equation, you get 11 equals 2b, so b equals 11 halves. Then from here, substitute that into here and solve for a and get a equals 1 half. So x plus 4 over 2x minus 3 squared equals a half over 2x minus 3 plus 11 halves over 2x minus 3 squared. Fine. Routine. And again, if you want to, in the calculus, you want to integrate the left side, you just do the sum of the integrals on the right side. All right, now, here's a problem. We have a denominator that has an irreducible quadratic factor. So here we have x squared cubed plus x squared. Well, there's an x squared factor here. So we can have a over x, b over x squared. Here's an x squared plus 1. It's irreducible, would mean you can't factor it, well, in this case, in the reals. You'd have to have an x plus 1 I times x minus I. So we put that x squared plus 1 underneath a cx plus d. So, okay. And we have to solve for C and D. And multiplying through by x cubed plus x, you get this equation. And then you distribute the x's and the x squareds and combine it out. X cubed times a plus c plus x squared times b plus d plus xa plus b equals 1x squared plus 2. And so we identify coefficients. A plus c has to be 0. B plus d has to be 1. A has to be a 0, and B has to be 2. So we have this 4 by 4 system, which after a little bit of work gives you these values. So x squared plus 2 over x cubed plus x squared equals 2 over x squared plus negative 1 over x squared plus 1. All right, let's try some other examples. Here they ask to find the form, don't find the coefficients. X squared over x minus 3 times x squared plus 4. Well, here's a linear factor. So you have a over x minus 3. Here's an irreducible quadratic factor. So I have x squared plus 4 underneath a linear numerator, bx plus c. And a, b, and c are the unknowns. Well, let's try this. X squared plus 4 over x squared minus 8x, 2x minus 8 is what? Okay, well, 14, not 4, 14. Okay, so we need to factor out x squared minus 2x minus 8. Comes out to x minus 4 times x plus 2. Okay, x plus 14 over x minus 4x plus 2. Okay, we have linear factors, x minus 4, x plus 2 underneath an a and a b. Find a and b. All right, so we do the usual method, which is distribute the multiply both sides by the denominator, x squared minus 4 times x plus 2. Get x plus 14 equals a times x plus 2, because the x minus 4 cancels out, plus b times x minus 4, because the x plus 2 cancels out. All right, now this is true for all values of x. I could identify coefficients, or I think just as easy is to put in special values of x. For example, try 4 to cancel this out, and try negative 2 to cancel this out. When x is 4, we get left side is 18, the right side is 6a plus 0, and this solves easily to a equals 3. When a is negative 2, this term cancels out as 0. This x plus 14 is 12. B times x minus 4 is negative 6b. 12 equals 0 minus 6b. And after a little, very small amount of algebra, b is negative 2. So x plus 14 over x squared minus 2x minus 8 is identical to 3 over x minus 4 plus negative 2 over x plus 2. Now here we're to factor out x minus 3 over x cubed plus 3x. Well, all right, rewrite the denominator as x minus 3 over x times x squared plus 3. X, that's a linear factor, so a over x on this side, plus. Here, x squared plus 3 is irreducible quadratic, so we put the bx plus c over x squared plus 3. Find a, b, and c to make this identical. Okay, as before, we multiply throughout by the denominator on the left, x times x squared plus 3, so it cancels, leaving an x minus 3 on the left, identical to a times. The x cancels, leaves an a times x squared plus 3. The x plus 3 over x squared plus 3 times x squared plus 3. X squared plus 3 cancels, leaves an x times bx plus c. All right. Okay, here I'm going to do this by coefficients. Left side is 0x squared plus 1x minus 3. The right side is ax squared plus 3a plus bx squared plus cx. Rewrite this as a plus b times x squared plus c times x plus 3a is identical to 0x squared plus 1x minus 3. Therefore, a plus b is equal to 0. C equals 1, that's easy. And 3a is negative 3. All right, this is a pretty sparse system. We already have c equals 1. If a equals negative 3, then a equals negative 1. And if a plus b is 0 and a is negative 1, then b is 1. That was relatively easy. So x minus 3 over x cubed plus 3x is identical to negative 1 over x plus 1x plus 1 over x squared plus 3. Okay. And when you get to the calculus, if you're told to integrate this, and that integral is the sum of these two integrals. And this is an easy one to integrate, and this is not that hard. So that's these.